Now, what if they say consider the points that are given on screen first? This is your x, y, z, x, y, z. It's a three-dimensional point, or should I say, a point in a three-dimensional space. So, obviously, you'll try to draw it. Try to draw it. Call this one my x. Call this one my z. Call this one my y. So on the x it went 1, on the y it went 3, on the z it went 2. Then the next time I try to draw that point. It's something like this. Okay. Point is just here. The whole idea of the vectors in 3D space is being able to construct, or should I say visualize where they are. So let's now, the problem is how far is it away from the origin. This is the origin to it, so then we call that OP. This is P, this is O. So we have to find the distance OP. Distance OP is equals to square of the change in y. You could just say 1 minus 0, get that one, and 3 minus 0, you get that, the change in z, and that all should be under your roots. Then you do your math there, you get 1, 9, 4, 5, making 10, 14, root 14. That is going to be your OP. OP is a vector. This is the distance between O and P. So we solve that. Now the next question you have to look at is like as the one on screen again. How far is P from the x plane? So x plane. So we need to first highlight the xy plane. So x plane, y plane is this plane on the floor, should I say. This is it. If they say how far is the point from this plane, they really mean to say how far is the point above. Let me consider xy as the surface. It's like how far is it above from the surface. So it is, this is how far it is above the surface. It is the z. So we have to find the z coordinate of the point. Okay, so the z coordinate of the point which is used here, it was 2. So we can easily give that. Therefore p is 2 units above xy plane, because I consider xy as a surface. This is the floor, and this is how much up is it. Okay, so it's like the altitude. This one is the floor, xy. Now the question they're throwing at us again is how far is P from the xy plane. What is an xy plane? Is this wall. First, planes, you have to see them as walls and floors and ceiling. That's how they are exactly. So this is the wall they're referring to. If they say how far is it away from this wall, they meant to say what is this? What is this called? This plane that points outward. This x that's point outward. It was y, right? So they mean just say give us the y, give us the y coordinate exactly, because they talk about x. The only remaining is y. Here they talk about x, y. The only remaining was z. We gave them z. Here we'll give them y. That's how much it is away from this wall. So to get the y coordinate, I come here, it was It was y was 3. I did recall it very well. It was 3, 3 units away, away from xy plane. This is how you look at it exactly. The planes, if they talk about xy, you give them the remaining. If they give you xz, you give them y. If they give you xy, you give them z. If it was the other thing, yz, you'll give them x. So that's how it is. So if the angle that OP makes with the x-axis, we're going to how do we say this thing? Whatever it is, and you'll just make a triangle there, and you have the side, and you do have the OP, origin to P. I think we did calculate that on the previous problem. It's going to be cos of that angle that you use, you may call it alpha angle here. I call it alpha, and because it's cos, look at the adjacent of which is x. X is 1 all over the hypotenuse. What was our hypotenuse? From the previous problem, we said our hypotenuse was roots 14. Then this is it. Then you solve your angle here, do the correct computation. So if you really did well in your computations, you're just going to land an answer like this one on screen. Now we have another problem on screen. It says assume that the positive x-axis are directly upward. As we said here, they're directly upward. Find the elevation angle. Elevation angle is something like this. If this was the surface, elevation angle is the angle here. But using our calculation, we can get an angle here that we call this. So we can do, because it's upright, perpendicular, we can do 90 minus, okay? So let me just do the math, you'll just see the rest. Okay, so we can get an angle that this one makes with the z-axis, of which is cos that angle is equals to, because it cos z, sorry, it's going to be z all over hypotenuse, and then that is going to be what angle you make on z. We have 2 on z. Hypotenuse, we said it was roots 14. Yes, it was roots 14. And you do your maths, do right computation, you get the angle. Why call it that thing? Then you get your angle. Oh, thank you. And with the right computations, this is what you get. Remember, this is the angle. Okay, let me just draw this one from the side view. These are the z, and these are the x-axis, or the y, it really doesn't matter. So the angle that we got here is this one, but we are required to find elevation angle. Let me call it elevation angle. We're required to get this angle, so it's just going to be 90 minus this thing. So for elevation angle, we're just going to say 90 minus our answer. So 90 minus 57.688, then do the right computation again, and with the right math, this is what you get. So the only reason why I did say these angles are complementary, because the elevation angle is just like here. So the angle that we were looking for was that made by the floor and that thing. So it is 90 degrees here. That's why I made them complementary, not like the other angles where we weren't allowed to do that. They were on the very same plane. So hope I do make sense.